Good morning, everyone. Nice to meet you again. Okay, this morning we are going to continue our chapter 14, section 2, volume of similar figure or solid. This is just the objective. Okay, before we go through to our new point, just answer to my question here. State the formula to identify the volume of the following solids. I have 4 questions. The first one just a cube, the second one a cuboid, the third one a cone, and the fourth one is a cylinder. Who remember about the formula of this solid? Yeah, good. Cube is present by the cubic of side. In the side they are all equal. Okay, the second one, volume of cuboid, length times breadth times height. And the third one, volume is equal to 1/3 of the base area. The base area as a circle, so pi r square. And the last one, the volume is equal to base area times height. Yeah, base area of a cylinder is a circle too, so pi r square times h. Okay, warm up. Table 14.2 show 3 cubes. Just complete the volume of the 3 cubes given. Here the table. It is 3 cubes, the first, second, and third. Length of the cube, the first cube is 1 centimeter, the second cube is 2 times of the first one, and the third one is 3 of the first one. Yeah, 3 centimeters. So what is the volume of the first cube, the second cube, and the third cube? So the volume of the first cube will be 1 centimeter cube. Yeah, and 1 cube become 1, and this is just 2 cube, so it will be 8 centimeter cube. How about the third one? The third one, 3 cube, it will be 27 centimeter cube, right? Okay, so the question, are they similar for the 3 cubes here? First, second, and third, are they similar? Explain your answer. Yeah, good, they are similar. Yeah, then all the ratios of corresponding sides of the 3 cubes are equal, so the 3 cubes are similar. Good. When the dimensions, you know dimension, right? Yeah, the 3 sides representing cube of a cube increase by factors of k, how does the volume change? Like what you know, the cubes given before, is it 1 centimeter side? Is it 2? 2 is just 2 times of the first side here. Yeah, to multiply by 2 get here, multiply by 3 get here, but now 2 multiply by k. So how does the volume change? Okay, so when we multiply by 2 cube, multiply by 3 cube, so we multiply by k, it means that we also multiply the volume by k cube. Okay, note, solids of the same type that have proportional corresponding linear measure, they are similar. You know, proportional corresponding linear measure, they refer to the side, and proportional corresponding side, so they are similar. Example, like these 2 cylinder A and cylinder B. You see, if you compare the radius of the cylinder A to its height, it means 6/4, and it is equal to 7.5 compared to 5. You use cross multiplication, you will identify that 30 equal to 30. It means these 2 cylinders, they are similar because of the ratios of the corresponding pairs of sides, they are proportional. Okay, move to our topic today, volume of similar solid. So I have two cones here, yeah, two similar cone, but if you identify the height is in lowercase, it is in capital, and this length is in lowercase, this is just capital. Also radius perpendicular to height here, also one is in lowercase and another one in capital. So if these two cones are similar, so we can compare the side like this. Yeah, they are proportional, so equal to k as a constant value. So we can identify volume by using capital letter V here to represent the big cone. Yeah, big cone. So the volume is 1/3 pi r square h. For the smaller cone by lowercase here v, so we get 1/3 pi r square h, the same thing, but we use different radius and height. So if we compare the volume, we identify that this is equal to k cube. Yeah, equal to k cube. So that's what we mentioned by using the cubes on the top. The volume will change by multiplying by the constant value cube, yeah, by k cube, when the sign increases by k, yeah, by a constant value. So the volume increases by multiplying by k cube. Okay, so just a key idea. Volume of similar solid we can identify by using the ratio here. So when the two solid similar, yeah, solid A and solid B are similar, so we compare volume of solid A to volume of solid B is equal to the cube of the ratio of the corresponding side. It means that now we use radius of the solid A compared to the radius of solid B. It is also true for another corresponding side. So in general, the ratios of volume of two similar solids is the cube of the ratios of their corresponding lengths. Yeah, such as this formula. Yeah, if I use V2 over V1 is equal to L2 over L1 cube. If I use V1, so I need to flip this one too. It becomes L1 over L2 cube. Okay, move to our next point. Just note, if two similar solids are made of the same material, then the ratios of their mass is equal to the ratios of their volume. It's mean like this. Yeah, M2 over M1 equal to V2 over V1. This is represent to mass of the second solid. This is just mass of the first solid. So the ratios of it equal to the ratios of the volume. Okay, so in general, the ratios of volume of two similar solids is a cube of the ratios of their corresponding lengths, and the ratios of their mass is equal to the ratios of their volume. It means we can write down like this. Okay, here. Move to our example. The figure shows two toy blocks which take the shape of a pair of similar cuboid. Here, the two blocks. This is we don't know V1, but we know L1. This is we know V2 and L2. So by using the volume of similar solid, we can identify the unknown volume of the first block. Find the volume of the first block. Solution. Yeah, we use a formula compare, and then we substitute the value of given value, and then we calculate. We will get V1 equal to 3 centimeter cube. Okay, move to second example. Two solid spheres of diameter 4 meters and 5 meters are made of the same material. Given that the smallest sphere has a mass of 120 kilograms, find the mass of the largest sphere. Solution. Okay, just let M1, V1, and L1 to be the mass, volume, and diameters of a smaller sphere respectively, and also with M2, V2, and L2 be the mass, volume, and diameters of a larger sphere respectively too. So I get the comparison or ratio of M2 M1 equal to V2 1, which I mentioned that the ratios of volume equal to the cube of the corresponding lengths here. the ratio corresponding length. So we just substitute the value given and calculate. We get M2 equal to 234 3/8 kilograms. Yeah, therefore the mass of the largest sphere is 234 3/8 kilograms. Okay, this is just your time to do classwork. Yeah, we have 2 exercises. Just work on it for 15 minutes and then submit your answer back to me. Thank you for your cooperation. Yeah, goodbye.